And 45 by 4 is 1, so the 1 will go. Yeah. Yeah, keep in mind too, there's the videos online. So if you need more help, look online and then come to office hours, okay? Yeah. You can always come to Miss Stevenson. She has it in the afternoon. All right. Today is the 3rd, yes, right? So we are continuing on, seniors. Yeah. Gentlemen, ladies. We're continuing on with yesterday's. We're doing level 3 today. So we're going to still be using the power rule and constant rule, but in today's lesson, we're going to be, or not to, using negative exponents, okay? So we have a few things that we need to remember before we get to today's examples. So I'm going to give you the rules for level 3 and 4, just so that we have them in the notes so I don't have to re-give them to you. Negative exponent rule. Can you guys see that? Okay. The negative exponent rule, in addition to the power rule and constant rule, will be used in level 3. Now remember, this is to change exponents that are in the denominator to be able to help you use the power rule. Remember, we're using the power rule for integration, not differentiation, okay? Because we're using the inverse this time. So I'm giving you the rules in context of things that we've seen so far for integration. So A is just going to be the coefficient. Remember, you can have a number in front of the x down here that just creates its own fraction. But we cannot use the power rule when your exponent is in the denominator. So we need to make sure that we are creating the reciprocal of x to the n and bringing the exponent to the numerator and make it negative. Okay? This goes back to what we did in probably November with the derivatives. So we're extending this negative exponent rule to the integration for power, the power rule for integration, because we cannot take the integral where there is an exponent in the denominator. So we're going to go back and forth between these, but this is just a reminder of your rules from November. The other rule that you're going to use, which we'll use on Monday, is the rational exponent rule. This is a level 4. So for those of you who have mastered level 3 tomorrow, on Monday what you'll do is you'll get level 4 stuff. So you can try and, ooh, I spelled rational wrong. Sorry. So you can try level 4 and attempt to get that level 4. We have 3 rational exponent rules. Rational means that it can be written as a fraction, it being the number. So if we have a times the square root of x, this square root can be written as ax to the 1/2. This right here is called the index. If there is no index, remember that the understood index is 2. These are also in or on that sheet that has the derivative rules. Okay? You don't have to memorize this. This is also on that sheet that has the derivative rules. So square root is the only one that doesn't have an index. Just like with here, there is an understood exponent of 1. Here there is an understood index of 2 for square root. But if we have another number as an exponent, instead of a 1, the numerator will be m. So if it's 3, it'll be 3. This is the exponent. Exponent is always in the numerator. Some of you, when we were doing this at the end of the year, still put the exponent in the denominator. Outside goes in the denominator. Inside goes in the numerator. I'm sorry, what'd you say? Okay, I'll try to slow down, but these are not new notes. This is all stuff that I talked about before. This is just all a review. And keep in mind too, I will be posting the video, so if you missed something or if you need help, let me know when you're doing the practice, okay? Yeah, it's next to the hand sanitizer.
You're recording right now? You're recording?
Yeah. Yeah, I'll be recording the videos from this point on, just so that if you're absent or if you miss something because you go to the bathroom or they pull you, it's online and you can just watch it. I mean, I'm doing this for you guys. I don't know why we're laughing. Okay. Can I go, Alejandro, or no?
No.
Can I go or no? Okay. Good? Okay. We can also have a different index. Remember, the index is the root. So if I have something other than square root, there's going to be a number here. So like a 3, a 4, a 7. I can still rewrite the exponent as a fraction, where the numerator is the exponent and the denominator is, ooh, I made a mistake. Sorry. This should be 2. That's my bad. I'm sorry. I skipped ahead in my notes. I'm sorry. Keep in mind that we are going to be able to go backwards and forwards with this. So if we start here, we're going to need to write it this way. Even with the negative exponents, we're going to need to write it this way in order to use the power rule. Once you use the power rule, you have to go back to whether it is a positive exponent or a radical. This is what we did way back in November and December. You have to be able to go back and forth between the different, not notations, representations. Okay, can I go down? All right. So let's talk about the scale and level expectations. So I'm going to give you guidelines on how to get that score and what is expected at each scale. So for all the scales, so 2, 3, and 4, you're going to need to make sure that you're showing your work. at least for the time being, you have to show your work until we get comfortable using those rules where we're adding and dividing instead of multiplying and subtracting. You have to make sure that you're reducing any fraction, whether that is reduced to a whole number or a reduced fraction. You have to make sure that you are reducing your fractions. You have to make sure you're also adding the constant of integration. You have to make sure you're adding the constant of integration. I think I was telling Maite, she got everything right except she forgot the plus c. So you need to make sure that you are adding the plus c. If you don't add the plus c, then you will not you will not get full credit. And I don't know if I said it in this class or not, I forgot. You have to make sure that you're putting y equals or f of x equals. Either one for your final answer. Okay, level 3, Naraj, I'll give this to you in a second, okay? Level 3, you'll see in a second what the examples are, but you need to make sure including all of these, so including showing work, reducing fraction, adding the plus c, and creating an equation, you have to make sure that you're making the exponents positive. And you'll see that in the examples in a second. Hi, Maite Mendez went to the bathroom more than 10 minutes ago and didn't sign out. Maite Mendez. Thank you. Okay. Bye. Maite. See me after class. For level 4, you also need positive exponents and radical form. Radical form. So not fractional exponents, you need to put it back under the square root, under the cubed root, the fourth root, etc., etc. John, what's that? So Naraja? The things that I'm writing down now are not in there. No, the ones right now. Ready? Okay. Oops, what's going on? Okay. So just like I did for derivatives, I'm going to give you some guidelines for these. Things to ask yourself when you're using integration or when you're working with the radicals or negative exponents. So these are not on there. For integration, you want to ask yourself or check integration. I think I spelled that right. You want to make sure that we have exponents in the numerator. If they're not, make sure you're using your rules to put them in the numerator. You want to also make sure that the exponents are fractions or whole numbers. If they're not, you've got to put them in there in order to use your power rule. You can't use your power rule for integration or differentiation if you do not have them as a fraction or whole number. And then right now, even though we have constant and power rule as our only rules, you have to ask yourself what rules are being used. Just a few more things before we get to the examples. For your final answer, and I don't know how many times I have to remind you guys, you have to do these things for your final answer. You have to make sure your exponents are positive. If they're not positive, you're going to have to flip them to the denominator. You're going to have to use your negative exponent rule to flip them to the denominator. Make sure that you have radical form. That means the square root. That means the cubed root. These are just examples. Fourth root, fifth root. Make sure it goes from fractions to radicals. Make sure you have y equals or f of x equals. If you don't have these things, you won't get the full credit, even if all of the other things are correct. Make sure you have simplified fractions. That means you might have, speaking of that, I'm not putting the exit ticket in the grade book from yesterday. I'll get them graded to you back tomorrow because you're the only class that took it, and I don't think it's fair that you're the only one that took it. Okay? Some of you forgot to simplify the fraction 15 over 6. Yes, that does not reduce to a whole number, but it does reduce. Some of you some of you did put like 2.5 or whatever the decimal is. I don't want decimals right now. We need reduced fractions. So this is 5 over 2. Yeah, it was 5 over 2. Okay? So you need a reduced fraction. Reduced fraction. No decimals, not 15 over 6. You need to make sure you're simplifying the fraction. Don't forget your plus c. Don't forget your constant of integration. And then don't forget to show work. Yeah. Yeah. Unless you guys want me to put it in the grade book. I mean, it wasn't looking good yesterday, so I don't know if you want me to put it in the grade book. Yeah, that's what I thought. You'll get to use it on your assessment tomorrow, though. When you're done writing this down, take out the sheet that has the examples on it. It's on the do now. The examples are on the do now. Raja, you need this? Thank you. Julian, are you done? Okay. Are we ready? Alejandro? Okay. All right, so let's look at the first example. This is a level 3, remember. You know it's a level 3 because we have negative exponents. These are not just positive exponents. So you want to ask yourself, are my exponents in the numerator? Meaning, do I have a denominator here? I don't have a denominator, right? Are you looking for the examples, Alejandro? Okay. Yeah, it's on that sheet at the bottom. So because my example, or my exponent is in the numerator, gentlemen. Okay. Because it's in the numerator, I can apply the power rule. I know I'm going to use the power rule because it's not a constant. We haven't done anything else. So I'm just going to use the power rule for integration. Walter. Joanne. The power rule says, what does the power rule say? What do I do to my exponent? See a lot of shoulders shrugging. It's in the notes from yesterday. What do I do to the power rule?
It's not from today?
No, it's from yesterday. We're going to add 1 to the exponent, and then what?
You add the same.
Yeah, it goes also in the denominator. Okay? So I'm going to add 1 to the exponent. And put that same thing in the denominator. These two things have to match. They have to match. Okay, for the power rule, they have to match. What are you missing here? Plus C. Don't forget your plus C. Am I done?
Yeah.
Okay, you would not get full credit.
No,
Why aren't you done?
because the exponent's negative.
No, well, it will be, but what else do you have to do first? Simplify. So we have y equals negative 2 plus 1 is negative 1 plus c. Are you done now?
No.
No. What do we have to do? Not yet. Reduce it if needed. So when we put this in the calculator, you see I'm circling my coefficients. I'm circling the number in the numerator and denominator to be able to divide it. When you divide 3 and negative 1, that gives you negative 3, x to negative 1 plus c. And now, Walter, what do we do? Yeah, we're going to change it to the positive exponent, and we just flip it to the denominator. So we have y equals negative 3 over x plus c. You can put over x to the 1. That's fine, but you do not have to. So you can have it as y equals negative 3 over x plus c, or x to the first plus c. Either, one of those are fine. Questions? Ready? Oscar Alejandro? No? Okay, let me know when you're ready. when Jaime comes back. Ready? Alejandro? Ready?
Sure.
Are you done copying? Okay. Example 2 is the integral of 9 over x to the 4th dx. Can I use the power rule yet? No. Remember, look at those questions. Are my exponents in the numerator? Is this in the numerator? No, it's in the denominator, so I need to make it to the numerator. To bring it to the numerator, you flip the sign of the exponent. What is the opposite of a positive? Negative. So this becomes a -4. A lot of students stop here. Rewriting it is not the final answer. You just rewrote it to help use the power rule. You're not rewriting it and then you're done. You still have to use the power rule. So y equals 9x to the 4 plus 1 over -4 plus 1 plus c. Are you done? No, you have to simplify some more. So y equals 9x to the -3 over -3 plus c. Does everybody see where I'm getting these numbers from? Does anybody have any questions about where I'm getting these numbers from? I need to simplify now. So if y equals -3x to the -3rd plus c. And now that I'm simplified, I need to take this negative and put it back in the denominator. Excuse me. Thanks. Keep in mind that when we have a coefficient, it creates a fraction when you put it back. So don't put -3 plus 1 over x cubed. Make sure you put the variable with the exponent underneath the coefficient. Questions? Yeah.
So the one that's boxed is the right answer?
That is the final answer, yeah. So these are my steps. So the first step is I did the power rule. I'm sorry, that wasn't my first step. My first step is writing it as a negative exponent, okay? Do you want me to label my steps?
No.
You sure? Okay. Then I used the power rule. Then I simplified by adding the exponent and the denominator. Then I simplified by dividing. And then I rewrote it using my exponent rule. Questions? Okay. Then for sake of time, I'm going to get to number 4 because it's the most complicated one. It just involves all the things that we've done so far. Are we done writing this down? Okay. Number 4 is the integral of 6x to the 5th, x to the 4th, 1, -2x to -3, plus 6 over x to the 8th, dx. That's it, right? Okay. Walter, what you want? Do I have any exponents that need to come to the numerator? Yeah, which one? The 8. So I'm going to rewrite this one so that it comes to the numerator. Questions?
Do the same paper rule.
It's on the bottom, right? Number 4? Is that not on there?
Well, which paper?
The one for today. It's not on there? Okay. So now I'm going to use the power rule because I've rewritten everything. I don't have any radicals. All of my exponents are in the numerator instead of the denominator. So I'm going to add 1 to the exponent, divide by that same thing. Add 1 to the exponent, divide by that same thing. Oops. What happens to that 1? What rule is that? So these are power rule. What is this rule? Constant rule. So what does this become? 1x. Bless you. And I'm still going to do the power rule here. This is the only thing that's different because it doesn't have a visible x. We have a rule that says if it's just a constant, we just add the x to it. We attach the x. Questions so far? And now I'm just going to simplify. Y equals 6x to the 6th over 6. Not plus, it should be minus. What? Where should it be negative 3? Oh, I see, right here? Yeah. X to the 5th over 5. 1x. Yeah.
What's the 8 not negative?
Missed it. Thank you. Simplify coefficients if necessary. So you see I'm circling the coefficients I need to simplify. 6 divided by 6 is 1. There's nothing to simplify here, so I just leave it like that. I think somebody asked me this at the beginning of class. Do you need to include your 1? No. But if you include there, I won't mark it wrong or right. I'll mark it right if you include it or not include it. Now this is what is tripping students up. Even though I have this minus sign, it's technically a negative. So I'm going to divide negative 2 by negative 2. So make sure if it is a negative or a minus sign next to the term, you are using that negative. So negative 2 divided by negative 2 is a positive 1. Positive 6 divided by negative 7 is negative 6 over 7, x to the negative 7th plus c. So this became a minus sign because a positive divided by negative is a negative, and this became a plus sign because a negative divided by negative is a positive. Are you done? No, you're not. You will not get full credit. Anybody know why you will not get full credit?
Why?
I don't know. You tell me. Let's look at the rules. Or the guidelines.
Negative exponent.
We have negative exponent. Those negative exponents are here, so we have to make sure we're changing those negative exponents.
Always gotta be positive. Always.
Always positive. Some students don't write that 1, and this is where it comes in handy to write the 1, because I need to put that in the denominator. If there's nothing there, you'll forget about the 1. And that is your final answer. Are there any questions, comments, or concerns? Do you want me to move it up? Like that?
Yeah.
Okay.
Wait, I have a question.
Yeah.
For the final answer, you can have exponents in the denominator.
You have to have exponents in the denominator if you have negative exponents. Okay? You gotta flip it. You gotta flip it. Okay? Jaime, do you have your hand up?
No.
Okay. Yeah. When Delilah comes back, if there's time. Because we only have 10 minutes. Yeah, you can't go. Where is the screen? There it is.